Okay, fine. So guys, if you're given y is equal to f of x, then you're required to get the approximate change in y. So the approximate change in y is written as approximate change in y, let's say with respect to x. This is approximately equal to dy dx. So for example, if you want to get the approximate change in y, then this will be approximately equal to dy dx multiplied with a small change in x. That's how we get small changes, guys. So let's take up an example. Given y is equal to 4x squared minus x, determine the approximate change in y. Determine the approximate change in y. So determine the approximate change in y if x is changing from 1 to 1.02. Now solution. From this formula here, approximate change in y is approximately equal to dy dx multiplied by a small change in x. So this will be approximately equal to, what is dy dx? Our y is 4x squared minus x. So our dy dx is 8x minus 1. Multiply this with small change in x. Sorry, this is small change in x. Multiply with small change in x. And what is the change in x? As we've been told, x is changing from 1 to 1.2. So the change in x will be 1.2 minus 1. This will be the change in x. Are we together? So what was so our answer will be equal to 8. What was the initial value of x? X was 1 before it changed. So 8, 1 minus 1 multiplied with the small change in x, which is 0.02. 8 minus 1 will give 7. So 7 multiplied with 0.02, this will give us 0.14. And that is the answer for small change in y. So the small change in y is given by that. So basically, these are quite direct questions for the small changes. For as long as you know the formula, then you should be able to evaluate. Let's take up another example. Let's take up another example. Let's say determine the change in y. So example 2, determine the change in y. So what is the change in y? If y, determine the change in y, if x changes from, so x changes from 2.50 to 2.51 when y is equal to 2x minus x squared. So if we want to get the small change in y, the procedure is the same. Let's start by writing the formula. So small change in y is given by dy dx multiplied by a small change in x. Okay, so what is our dy dx? Differentiate this equation to get dy dx. We'll have 2 minus 2x multiplied with the small change in x. X is changing from 2.50 to 2.51. So the small change in x will be 2.51 minus 2.50. And what was the original value of x? It was 2.50. So I have 2 minus 2 into 2.5. And then all this is multiplied by 2.51 minus 2.50. That is 0.01. So if you evaluate that, that should give us, so wait, we've been told x is changing from 2.5 to 2.51, yeah? So if you evaluate that correctly, what do we get? So if you multiply this, that you're going to get minus 0.03, which basically is the change in y. Okay. Final example, guys. Final example. So number 3, you're told y is equal to 5 over x. And then x changes from 2.50 to 2.51. Determine small change in y. Determine this. So from the original example, small change in y is approximately equal to dy dx multiplied by a small change in x. What is our dy dx? So I'll write first of all y as 5x raised to power minus 1 if you bring this x up. So differentiating that to get dy dx, we have minus 5x raised to power minus 2. Then multiply this with small change in x. X is changing from 2.50 to 2.51, so the change is 0.01. What was the original value of x? 2.50. So we have minus 5 into original value of x, 2.50 raised to power minus 2, and then all this multiplied by 0.01. And if you evaluate that, you will get that the small change in y is equal to minus 0.0081. So that's the last application of differentiation.